In the infinite darkness of space, beyond the comforting glow of our sun, lie worlds so alien, so extraordinary, that they challenge everything we thought we knew about the universe. Tonight, we embark on the ultimate journey, a voyage through the cosmos to witness sights that defy imagination. Picture this: a planet where it rains molten glass sideways at 400-500 miles per hour, a world covered in oceans of liquid methane beneath skies of orange haze, a place where diamonds fall like snow through atmospheres of crushing pressure and unimaginable heat. These aren't scenes from science fiction. These are real worlds, orbiting distant stars, waiting to tell us their secret. I'm your guide on this cosmic odyssey, and together we're about to discover that the universe is far stranger and more beautiful than we ever dared to dream. So buckle up, space travelers. Our vessel departs now. Destination: the alien worlds that populate our galaxy. What we'll find there will change how you see the cosmos forever. Before we venture into the alien unknown, let's take one last look at our pale blue dot. From space, Earth appears as a tiny marble, suspended in the void, fragile, precious, and utterly unique. But is it really? For centuries, humans gazed up at the night sky and wondered, are we alone? Do other worlds exist beyond our solar system? The ancient Greeks speculated about it. Galileo pointed his telescope toward the stars, hoping to find answers. But it wasn't until 1995 that we got our first confirmed glimpse of an alien world. The planet was called 51 Eridani, B, a gas giant, orbiting a star 51 light-years away. It was nothing like Earth, but it was something magnificent. Proof that our solar system wasn't the only game in town. Since then, we've discovered over 50 exoplanets, each one telling a different story about how worlds can form and evolve. Now, imagine if we could actually visit these distant realms. What would we see? What would we feel? What wonders await us in the cosmic deep? Our journey begins as we accelerate past the speed of light, leaving behind the familiar planets of our solar system. Mars shrinks to a red pinprick. Jupiter's great red spot becomes just a memory. Soon, even the sun itself fades to just another star among billions. We're entering interstellar space now, that vast emptiness between star systems. But even here, in what seems like perfect void, there are surprises. Rogue planets' worlds, ejected from their home systems, drift in eternal darkness. Some of these cosmic wanderers might harbor life, warming themselves through radioactive decay or tidal heating, creating hidden oceans beneath frozen surfaces. But our destination lies ahead. Star systems where alien suns cast their light on worlds beyond imagination. The Hellish worlds. Our first stop, HD 189,733b, a planet that redefines the meaning of hostile environment. From a distance, this world appears deceptively beautiful, a brilliant blue marble that might remind you of Earth. But don't let that azure glow fool you. As we descend through its atmosphere, the truth becomes terrifyingly clear. This isn't water blue we're seeing. It's the result of silicate particles suspended in the air. The temperature here reaches 800 degrees Fahrenheit, hot enough to melt copper. But temperature is the least of our worries. The winds on HD 189,733b blow at over 500 miles per hour. That's nearly 6 times the speed of sound. And those silicate particles I mentioned, they're actually microscopic glass shards, creating storms of molten glass that scream across the planet's surface at hypersonic speeds. Imagine standing on this world if you could survive for even a split second. Above you, clouds of vaporized rock dance in the alien sky. The air itself is a weapon. Each breath would be like inhaling liquid fire mixed with ground glass. This is a planet where the very atmosphere wants to kill you. Yet, there's a terrible beauty here. At the boundary between day and night, the Terminator line, we witness one of the most spectacular sights in the known universe. Here, in the perpetual twilight, metallic snow begins to fall. Not water snow, but tiny droplets of vaporized iron and other metals, condensing in the slightly cooler temperatures and drifting down like deadly confetti. But HD 189,733b isn't alone in its hostility. Let's visit another world where the very rain is made of metal. On WASP 76b, the dayside temperatures soar to over 40 degrees Fahrenheit. Here, iron doesn't just melt, it vaporizes completely, rising up into the atmosphere as metallic clouds. As we move to the night side of this tidally locked world, something magical and terrifying happens. The iron vapor cools and condenses, creating droplets of liquid metal that fall from the sky like a deadly precipitation. It literally rains liquid iron on WASP 76b. Standing on the night side of this world, you would witness an iron rainstorm, each droplet glowing red-hot as it falls through the thick atmosphere, creating streams of molten metal that flow like lava rivers across the planet's surface. These hellish worlds remind us that the universe doesn't play by Earth's rules. They're laboratories of extreme physics, showing us what happens when planets form too close to their stars, where the fundamental forces of nature create environments so alien that they stretch the limits of our imagination. The ocean worlds. Now, let's journey to calmer waters quite literally. Our next destination, Gliese 1214b, a world that might be the closest thing to a true ocean planet that we've discovered. As we approach this super-Earth, located 40 light-years from home, we're struck by its alien beauty. The entire planet appears to be covered by a global ocean, deeper than anything on Earth. But this isn't an ocean of familiar H2O in its liquid form. This is something far more exotic. The pressure at the surface is so immense that water exists in a state unknown on Earth, a hot ice called Ice the Seven. Imagine diving into an ocean where the water is simultaneously liquid and solid, where the rules of physics create forms of matter that seem to defy common sense. But the real magic happens as we descend deeper into this alien ocean. The pressure increases exponentially, creating layers of different exotic ices. First Ice 7, then Ice X, and deeper still, forms of ice that only exist in the most extreme conditions in the universe. At the very bottom of this ocean, compressed by the weight of hundreds of miles of water above, we might find Ice 8, a form of ice so dense and strange that it exists nowhere else in our solar system. Yet life, as we've learned, has a way of surprising us. In the middle depths of this ocean world, where temperatures stabilize and pressure creates a perfect balance, there might be layers where liquid water, true liquid water, exists in vast, planet-spanning seas. Picture swimming through these alien waters. Above you, miles of exotic ice. Below, more miles of even stranger ice formations. But here, in this magical middle zone, liquid oceans that dwarf all of Earth's seas combined. What creatures might call such a place home? Our journey continues to an even more intriguing ocean world, Ka-2 18b. This super-Earth, discovered in its star's habitable zone, has captured the imagination of scientists worldwide. Recent observations have detected something remarkable in its atmosphere: water vapor. But Ka-2 18b holds an even more tantalizing secret. Beneath its hydrogen-rich atmosphere might lie global oceans of liquid water, protected from space by a blanket of gas thick enough to maintain stable temperatures across the entire planet. Standing on a floating platform in Ka-2 18b's oceans, you would see a sky unlike anything on Earth. The atmosphere, rich in hydrogen and helium, would create optical effects that paint the heavens in impossible colors. Sunsets would last for hours as light bends and refracts through layers of alien gases. The oceans themselves might be warm and inviting, heated by geothermal vents and the planet's own internal warmth. Imagine diving into these waters, where bioluminescent organisms, if they exist, might create light shows that put Earth's aurora borealis to shame. But perhaps the most exciting possibility is what we might find in these alien seas. On Earth, every drop of water harbors life. Could the vast oceans of these distant worlds be teeming with alien organisms evolved over billions of years in environments we can barely imagine? The search for life in these cosmic oceans has become one of the most exciting frontiers in modern astronomy. Each new discovery brings us closer to answering that fundamental question: are we alone? The Diamond Worlds, our cosmic voyage, now takes us to worlds that literally sparkle with unimaginable wealth. Welcome to the Diamond Planets worlds, where carbon has crystallized on a scale that defies comprehension. Our first stop, 55 Cancri E, a planet so rich in carbon that its surface is likely covered in diamond formations kilometers thick. As we approach this super-Earth, the light from its parent star refracts through a landscape made of pure crystal, creating rainbow prisms that dance across the horizon. Walk across the surface of 55 Cancri E, and you would literally be walking on diamonds. Not small gems, but massive crystalline formations, diamond mountains that rise toward alien skies, diamond plains that stretch beyond every horizon, diamond caves that burrow deep into the planet's interior. The temperature here reaches over 900 degrees Fahrenheit, hot enough to melt gold, but not hot enough to destroy the diamond formations that give this world its incredible character. Instead, the extreme heat creates something even more spectacular: diamond rain. In the upper atmosphere of 55 Cancri E, carbon vapor condenses under the intense pressure, forming tiny diamond crystals that fall like the most precious snow in the universe. Each snowflake is actually a microscopic diamond, and they fall by the billions, constantly resurfacing the planet with layers of crystalline wealth. But the true spectacle happens during the planet's day-night cycle. The best, 55 Cancri E, is tidally locked to its star, meaning one side faces eternal day while the other experiences perpetual night. At the terminator line, the boundary between these two worlds, something magical occurs. The temperature differential creates massive storms of diamond dust that sweep across the landscape like glittering tornadoes. These storms, visible from space as shimmering spirals of light, redistribute the planet's crystalline surface in patterns that change over time, making this world a constantly evolving work of cosmic art. Now imagine standing on the night side of this diamond world. The surface, cooled by the absence of starlight, would be covered in formations of pure crystal that stretch in every direction. Above you, the alien stars would shine through a thin atmosphere, their light catching and refracting through the diamond landscape, creating a natural light show that turns the entire surface into a cosmic disco ball. But 55 Cancri A isn't the only diamond world in our galaxy. Deep space observations have revealed other carbon-rich planets where similar processes might be occurring. On some of these worlds, the diamond formations might be even more extreme. Picture a planet where diamond formations have grown for billions of years, creating crystalline structures the size of continents. Imagine diamond canyons carved by ancient rivers of liquid carbon, diamond spires that rise hundreds of miles into the atmosphere, diamond caves that honeycomb entire regions of the planet's crust. These diamond worlds challenge our understanding of planetary formation and evolution. They show us that the universe is capable of creating beauty on scales we never imagined. Worlds where the most precious substances on Earth are as common as sand on a beach. Yet perhaps the most incredible thing about these diamond planets isn't their wealth. It's what they tell us about the diversity of worlds in our galaxy. If planets can be made of diamond, what other impossible worlds might be waiting for us to discover? The frozen realms. Our journey now takes us to the frozen frontiers of space, where alien worlds exist in states of perpetual winter that make Antarctica look tropical. But don't mistake these ice worlds for lifeless wastelands. They harbor some of the most intriguing possibilities for alien life in the universe. Welcome to TRAPPIST-1e, a world locked in eternal winter, orbiting a red dwarf star, in a system that has captured the imagination of astronomers worldwide. As we descend through its thin atmosphere, we see a landscape that seems familiar, yet utterly alien. Vast ice sheets that stretch beyond every horizon, but composed not just of water ice, but frozen carbon dioxide, methane, and exotic compounds that exist nowhere on Earth. The surface temperature here hovers around -80 degrees Fahrenheit, cold enough to freeze the air you breathe. Yet beneath this frozen exterior lies one of the most exciting discoveries in modern astronomy: the potential for liquid water oceans hidden beneath kilometers of ice. Using our advanced sensors, we penetrate the ice sheet and discover something remarkable. Deep below the surface, heated by tidal forces and the planet's own radioactive core, vast liquid oceans slosh in eternal darkness. These subsurface seas might contain more water than all of Earth's oceans combined. Imagine descending through the ice of TRAPPIST-1e, through layers of frozen gases and exotic ice formations, until you break through into the liquid realm below. Here, in the eternal night of this alien ocean, hydrothermal vents might spew mineral-rich water into the sea, creating oases of warmth in the cosmic deep. But TRAPPIST-1e has an even more intriguing secret. This frozen world experiences something no planet in our solar system does: synchronized orbital resonances with its neighboring planets. As these worlds dance their gravitational ballet, they flex and stretch TRAPPIST-1e's interior, generating heat that might keep those subsurface oceans liquid for billions of years. Our voyage continues to an even more extreme frozen realm, Proxima Centauri b, the closest confirmed exoplanet to Earth, just 4.2 light-years away. This world, tidally locked to its red dwarf star, presents us with a planet of two faces. On the day side, temperatures might be warm enough for liquid water, but the night side, our current destination, is a realm of perpetual Arctic conditions. Here, we find something that challenges every assumption about frozen worlds: ice formations that defy the laws of physics as we understand them. The extreme cold, combined with the planet's unique atmospheric composition, creates ice structures that seem to grow like living things. Spires of frozen nitrogen reach toward the alien stars, shaped by winds that have blown for millions of years without interruption. Walking across the night side of Proxima Centauri b would be like exploring an alien ice sculpture gallery. Formations of frozen atmosphere create bridges, arches, and spirals that stretch for kilometers. Some of these ice formations are so delicate, they seem to float in the thin air, held together by nothing more than the planet's low gravity and the intricate balance of sublimation and condensation. But perhaps the most remarkable feature of these frozen worlds is what happens at their terminator lines, the boundaries between day and night. Here, we witness some of the most dynamic weather in the known universe. On TRAPPIST-1e, massive storms of frozen gases sweep back and forth across this boundary, carrying ice particles from the night side to the day side and back again. These storms, visible from space as swirling white hurricanes, constantly reshape the planet's surface, creating new ice formations while destroying others. These frozen worlds remind us that ice isn't just water in its solid state. It's a medium for creating some of the most beautiful and complex structures in the universe. They show us that even in the coldest, most seemingly hostile environments, the fundamental forces of nature continue to create art on a planetary scale. And deep beneath their frozen surfaces, in hidden oceans warmed by the fires of planetary cores, they might harbor the greatest discovery of all: alien life, evolved in isolation, waiting for us to find it in the cosmic deep. The worlds of perpetual storms. Hold on to your seats, fellow space travelers, because our next destination will test the limits of what we consider survivable weather. We're approaching the storm worlds, planets where the very atmosphere is in a constant state of violent upheaval, creating weather systems that make Earth's most powerful hurricanes look like gentle summer breezes. Our first stop, HAT P7b, a gas giant where the winds never stop and the storms never end. As we enter this planet's atmosphere, we're immediately struck by the sheer scale of the meteorological chaos surrounding us. This isn't weather, this is atmospheric warfare on a planetary scale. The winds here blow at over 30 miles per hour, fast enough to circle the entire planet in just 6 hours. But these aren't ordinary winds carrying water vapor and dust. These are streams of vaporized metals, titanium, vanadium, and iron, heated to over 40 degrees Fahrenheit and flung around the planet at hypersonic speeds. Imagine flying through HAT P7b's atmosphere. Around you, metallic clouds swirl in formations the size of continents. Lightning bolts, made not of ordinary electricity, but of plasma, heated to temperatures rivaling the surface of stars, arc between cloud formations that stretch from pole to pole. The lightning on this world doesn't just illuminate the sky, it transforms it. Each bolt is powerful enough to temporarily ionize sections of the atmosphere, creating aurora-like displays that paint the alien heavens in colors that don't exist in Earth's spectrum. But the true spectacle of HAT P7b lies in its weather patterns. Unlike Earth, where storms eventually dissipate, the storms here are powered by the planet's proximity to its star and its rapid rotation, meaning they can rage for centuries without weakening. We witness super hurricane storm systems larger than Jupiter's Great Red Spot that have been spinning for thousands of years. These atmospheric monsters create wind patterns so complex that they form their own ecosystems of smaller storms, each one feeding off the energy of the larger system. Our journey through the storm worlds continues as we visit GJ 1214b, a world where the very concept of weather takes on new meaning. Here, the atmosphere is so dense that it creates pressure conditions unlike anything in our solar system. The storms on GJ 1214b don't just move through the atmosphere, they reshape it. High-pressure systems create regions where the air becomes so dense it's almost liquid, while low-pressure zones create near-vacuum conditions that stretch for hundreds of miles. Flying through this world's atmosphere would be like navigating through an ocean of gas where the water constantly changes its density. One moment, you're moving through air thick as soup. The next, you're in a region so thin that space itself seems to beckon just overhead. But perhaps the most remarkable feature of GJ 1214b's storms is their electrical activity. The dense atmosphere creates conditions perfect for generating static electricity on a scale unknown on Earth. Lightning bolts here can stretch for thousands of miles, creating electrical discharges that temporarily turn sections of the atmosphere into plasma. These plasma storms create their own light, making the planet glow like a cosmic lantern that can be seen from light years away. From space, GJ 1214b appears as a world in constant electrical flux, with lightning networks that pulse and flow across its surface like the nervous system of some cosmic organism. The most incredible sight on these storm worlds might be their polar regions, where the atmospheric dynamics create phenomena that exist nowhere else in the known universe. On HAT P7b, the convergence of global wind patterns at the poles creates permanent storm systems that drill down through the atmosphere like cosmic tornadoes. These polar storms, fed by the constant flow of superheated metallic gases, create vortexes that extend from the upper atmosphere all the way down to the planet's core. Standing at a safe distance from one of these formations, if such a thing were possible, you would witness a tunnel of swirling plasma and metallic vapor that reaches from the surface to space itself. These storm worlds show us the awesome power of atmospheric dynamics unleashed on a cosmic scale. They remind us that weather isn't just a local phenomenon. It's one of the fundamental forces that shapes worlds and creates some of the most spectacular displays in the universe. In these perpetual tempests, we see nature as the ultimate artist, using wind and lightning, pressure and plasma to create masterpieces of motion. The impossible world. As our cosmic voyage nears its end, we arrive at destinations that challenge the very foundations of planetary science. These are the impossible worlds, planets that, according to everything we thought we knew about how solar systems form, simply shouldn't exist. Welcome to TOI 849b, a planet that has left astronomers scratching their heads and rewriting textbooks. What we're looking at here defies explanation. A world with the mass of Neptune, but compressed into a space barely larger than Earth. It's as if someone took a gas giant and stripped away its entire atmosphere, leaving behind only its dense metallic core. Standing on the surface of TOI 849b would be like standing on a world made of pure metal. The gravity here is so intense that it would crush any visitor from Earth, yet somehow, this world has maintained its structure, despite orbiting incredibly close to its star. So close that it completes a full orbit in just 18 hours. The surface of this impossible world glows red-hot from stellar radiation. Yet beneath that molten exterior lies one of the densest concentrations of heavy metals in the known universe. We're talking about a planet-sized ball of iron, nickel, and exotic elements forged in the hearts of ancient stars and somehow concentrated into this one impossible location. Our journey continues to an even more baffling destination, LTT 9779, a planet that exists in what astronomers call the Neptune Desert, a region around stars where Neptune-sized planets are never supposed to survive. This world receives 170 times more energy from its star than Earth receives from the Sun. By all rights, its atmosphere should have been stripped away billions of years ago, leaving behind a barren rock. Instead, LTT 9779b has somehow retained a puffy, inflated atmosphere that makes it one of the least dense planets ever discovered. Flying through the upper atmosphere of LTT 9779b is like moving through cosmic cotton candy. The air here is so thin and inflated by stellar radiation that the planet's density is less than that of water. It's a world that seems to float in space, held together by forces we don't fully understand. Yet this impossible survivor harbors another secret. Its atmosphere is constantly being replenished. Somehow, this world has found a way to manufacture new atmospheric gases as fast as its star strips them away, creating a dynamic equilibrium that allows it to exist in a place where no planet should survive. But perhaps the most impossible world of all is one we discovered orbiting a pulsar, the remnant of a massive star that exploded in a supernova. PSR Bone 1257 plus 12b shouldn't exist at all. Nothing should be able to survive the death of its parent star. Yet here is a world that not only survived, but thrived in the aftermath of cosmic apocalypse. Standing on PSR Bone 1257 plus 12b would be like standing in the eye of a cosmic storm. Above you, instead of a normal star, pulses a neutron star, a city-sized object containing more mass than our sun, spinning 161 times per second, and emitting beams of radiation that sweep across space like a cosmic lighthouse. The sky here would be painted with aurora displays unlike anything in the universe, as charged particles from the pulsar interact with whatever remains of this world's magnetic field. These aren't gentle aurora like we see on Earth. These are violent displays of energy that turn the entire sky into a canvas of impossible colors. Yet somehow, this impossible world continues to orbit its dead star in perfect precision, a testament to the universe's ability to create order from chaos, beauty from destruction. These impossible worlds remind us that the universe is far more creative and resilient than we ever imagined. They show us that planetary formation and survival can take paths we never considered, creating worlds in places we thought were impossible, and finding ways to exist under conditions that should be lethal. Each of these impossible worlds teaches us something new about the fundamental forces that shape the cosmos. They're laboratories where physics is pushed to its limits, where the laws of nature create outcomes that seem to defy logic, yet somehow work perfectly in the grand scheme of the universe. As we prepare for the final leg of our journey, these impossible worlds serve as a reminder that in the vast expanse of space, impossibility is just another word for not yet understood, the return home. And so, fellow travelers, our voyage through the alien worlds comes to an end. As we turn our cosmic ship homeward, accelerating back through the light years toward our pale blue dot, let's take a moment to reflect on the incredible sights we've witnessed together. We've walked on worlds where it rains molten glass and snows diamonds. We've explored oceans deeper than anything on Earth, hidden beneath ice sheets on frozen planets orbiting alien suns. We've witnessed storms that rage for centuries and lightning that turns entire atmospheres into plasma. We've discovered that the universe is far stranger, far more beautiful, and far more creative than we ever dared imagine. Each alien world we visited told us something new about the infinite ways that matter and energy can combine to create wonders beyond our wildest dreams. But perhaps the most important thing we've learned is this: in all the cosmos, with all its alien worlds and impossible planets, there's still something special about that pale blue dot we call home. Earth, with its gentle rains and breathable air, its protective magnetic field and stable climate, remains a rare jewel in the cosmic ocean. Yet our journey has also shown us that we're not alone in the universe, not in the way we once thought. While we may not have found alien life on this voyage, we've seen that the universe is full of worlds where life might flourish, where the conditions for biology might exist in forms we've never imagined. As we dock at our home planet, as Earth grows large in our view screen once again, we carry with us the knowledge that somewhere out there, in the vast darkness between the stars, alien worlds spin in the light of distant suns, each one a unique experiment in the art of planetary formation. The universe is vast, it's strange, it's beautiful, and it's full of worlds waiting to tell us their stories. Our voyage to the alien worlds ends here, but the real journey, humanity's quest to understand our place in the cosmos, has only just begun. Thank you for joining me on this incredible adventure. Until next time, keep looking up at the stars and wondering what other impossible worlds are waiting for us to discover them.